Welcome back. How would you like to run C++ on our products and even use an online compiler to get your projects going without installing anything? Let's talk about that. C++ and C are the most popular languages when it comes to microcontroller. They are the basis of everything. Even tiny CLR OS that let you run C# and VB code on your hardware, it's written in C++, C++. So at some point, you would have to use C++ to tweak things or do things in real time. So for example, Tiny CLR OS gives you the option to build your own libraries and extend the operating system to do certain things that need to be in real time, or it's like you need to calculate a checksum, for example. There's a lot of computation that needs to happen, and doing that through an interpreted language would be a lot slower. So you can add a little module in C++ that will handle that piece for you. Now, what if you want to just get right into the processor? You don't want to use any operating system, or you have your own, or you just want to get right down there. You can do it in assembly even. So the way to do C++ on any product is really straightforward, because once you get to the processor, if the processor is not locked, then you can just grab, let's say, GCC, the GNU CCC compiler, and then you can use that to compile your application and load that right onto the microcontroller. Now, there are difficulties here because yes, you compile your code, but then your code has to run on a specific microcontroller, and each one has like different memory and flash, and there's no operating system to handle anything, so you'd have to add like libraries to handle networking and file system, and even SPI and I2C, everything needs a library. And then there are tons of libraries online. If you know what you're doing, or if you've done it in the past, it's not an issue. Now, a better path would be to use the ARM Mbed tools. Mbed is basically, just to make it like a really simple description, you can go online and read more about Mbed on mbed.com or mbed.org. It's a website where you can create an account. I'm just going to explain it in like simple terms. You can log in, and it gives you like an online IDE compiler. It's pretty nice actually for being online. It's surprising how much work they put into it. And then from there, it just looks like any IDE you would install on your PC. And in the back end, there's an operating system or libraries that you would use for certain boards and microcontrollers. So somebody would port or add the libraries for their product on Mbed, and then when you log in to your IDE, because you're not installing, you're just logging in, so it's customized to your needs. And then from there, you pick that specific board, and this will automatically import all the libraries into the project magically in the back end. And then you can just add a simple piece of code to blink an LED, and you would be on your way in really seconds. And that's what I'm going to talk about today. So, and what I'm going to do is show you how to do that on the BrainPad. We did talk about Python before, so this is very similar, the way you would load the program on your BrainPad. And like I said in the previous video, you can always go back to Tiny CLR. So going forward in the future, all our products are open. We let you run any software on our products, and we let our software, Tiny CLR OS, run on any other product. So we're trying to open the door on both directions here, making it easy for you to move from one platform to another, on the software front and the hardware front. So the first thing you would do to compile C++, and by the way, this is an important thing to mention. What's nice about Mbed is that, yes, you have this beautiful online IDE and you can compile your project, but then there's an export feature. So you can export to like Kiel, for example, or just pure GCC, and this will give you the project files and everything you need. And then you can build that from your local machine. You don't have to be online to do that. So even if you don't really like you want to get more advanced and you want to use GCC or Kiel, it might be a good idea just to start with Mbed anyway, just to test the blinking LED or a few things, and then you can move that on your desktop and do the development on locally, if that's what you want to do. So the first thing you would do, you go to the developer website, the developer section on the Mbed website, which is developer.mbed, that's mbed.org. And from there, you would see the compiler button. You click on compiler, and this will open up the compiler section. Of course, you have to be logged in. If you don't have an account, you need to create an account and go to the compiler. Once you're logged in the top right corner, this is where you would pick which board you want to use. So the whatever code you're writing, it's compiled for that specific platform. So I would click on the platform in the top right corner, and from there you would have to select one of the available platforms. Now, the ones you have selected in the past, they show at the bottom, so you can just quickly go ahead and select it again. And if it's not there, and it will not be in your case, if this is the first time you're doing it, you just click on Add Platform. And when you click on Add Platform, from there, it will give you a list of all available platforms on the website. Now find the Nucleo F401. The F401 is the processor, the same processor used on the BrainPad. So the board name is different, but it's the same processor, so whatever you do, it will just run on the BrainPad or any other board that is F401 for that matter. So find the 401, go to that page, and then on that specific page, click on Add to your Mbed compiler. So we click on that, and this adds it back to my compiler. Now I can go back to my compiler and select that platform and create new project. And under new project, in the options, now in the platform, I would have Nucleo F401RE. That is the platform the project will be for. From the templates, I will pick the very first one, which is Blinky LED test for ST Nucleo boards. So select that, and you need to give your program a name. You can go ahead and name it, whatever you wish. So give it a name. Now we have a new project, and it's gonna start with a project, giving me different files, and all I care about really is main.c++. If I look at main.c++, it's a really simple, since I selected the blink LED example, it's a really simple loop that is setting LED 1, waiting 200 milliseconds, setting the LED off, and then waiting 1 second. Now, if you look at the top, it says the my LED, it's using the LED on the Nucleo board. I don't know which pin that would be, but what I know is the blue element on this RGB light bulb, and this is what we did on the Python example. If you remember, it was PC6. So let's do PC6, PC_6, and now this program will simply blink the blue LED. Click on compile, and this will go through the compilation, and then it will prompt you to download the file. This is your binary file that you just need to load on the processor, and you would have a blinking LED. Now, to load a binary save that file, and to load a binary file through the DFU mode, the instructions are under our STM32 bootloader section on our documentation, but I'm going to show you in the video here really quick. You would start by opening, after you install the ST tools, you would start by opening DFU file manager, and in the DFU file manager, you would select it gives you two options. You would select the option that you want to generate a DFU file. The DFU file, it's what's used to, that goes on through USB onto the microcontroller. Select that. And then on this window here, there's a multi-bin button. Click on that. And then on multi-bin, you would select the file we have just downloaded earlier. Let me select the file. Now, the binary file is just the code. It doesn't know where in memory that file should go, so you need to tell it where that goes. And that goes to 08, you need to change that address, 080000. That's 6 zeros. So 108 and then 6 zeros. So that's 1, 2, 3, 4, 5, 6. Make sure. Now add to list. Okay. That's all we have to do. Now click generate. and this will generate, give it a name, and this will generate a DFU file. Now we have a DFU file. Now we can deploy this the same way we would deploy the bootloader if you've done that in the past, which you would find DFU SE demo software, and click choose that file. And before, you would have to set the your board in the DFU mode. And the way you would do that, you click on boot 0 on your board, click reset, release, keep holding boot, now release boot. And now the DFU, the software you have open, the FUSE demo program, will see the board. And now you can click on upgrade. Or if you haven't clicked choose and you selected the file, make sure you do that. Now click on yes. So erasing, deploying, it's fairly quick because it's a small program, and now it's done. And now my program is on the BrainPad. If everything was done correctly, the LED will start blinking after I hit reset. Here we go. That's C++ running on the BrainPad. And for that matter, it's the same processor on the Fez. You can run the exact same program on the Fez. Well, you're not supposed to know what the Fez is. It's a beautiful board. We'll talk about that next. See ya.